Hi folks, we're going to take a look at number 19 on page 176. So here I asked you to use these functions and to determine their characteristics. So one thing I notice that's common between these two functions is they're both with a higher degree in the numerator than in the denominator. So I know that the end behavior is going to be approaching positive or negative infinity. And because it's one larger in terms of degree than the numerator in terms of the denominator, it's going to approach positive or negative infinity along a line. So it's going to have an oblique asymptote. All right, so let's start by factoring this first one out. So this is x minus 4, x plus 1 over x minus 2. So nothing reduces, so there's not going to be any holes. So I can now start analyzing this function. So the domain will be all real numbers except x equals 2. All right, we go to the x-intercepts. Now that it's factored, I can see that the x-intercepts are going to be 4 and negative 1. If I want to look for the y-intercept, I can just put 0 in for x. So we have negative 4 times 1 divided by negative 2. So that's negative 4 over 2 is 2. All right, the vertical asymptotes. Well, there's only one. It's going to be x equals 2. Okay, now let's look for the end behavior. All right, so I know it's going to approach positive or negative infinity, but we know that it's going to do so in a very particular way. It's going to approach a linear oblique asymptote. And the way we determine the equation of that asymptote is we actually perform the division on this rational expression. All right, now since I'm dividing by a linear divisor, I can use synthetic division. So 2 is going to represent my x minus 2, and then I have 1, negative 3, negative 4, my coefficients. So 1, that's going to be 2, negative 3 plus 2 is negative 1, negative 2. I don't actually care about the remainder here because I know that that term is going to be what's approaching 0. All I care about is the quotient. All right, so my end behavior is going to be an oblique asymptote of y equals x minus 1. All right, so as x goes to positive infinity, it's going to approach the line y equals x minus 1, and as x goes to negative infinity, it's also going to approach the line x minus 1. All right, so let's go to the second one here. So again, step 1 is to factor. So this is going to be x plus 2, x minus 1. Here I can factor out a common factor of 2. X minus 2. So again, no holes because nothing reduces. So now I can go ahead and analyze the function. So the domain, all real numbers except again, x equals 2. All right, my x-intercepts in this case here are going to be negative 2 and 1. Okay, my y-intercept is going to be, I'll stick in 0, so 2 times negative 1 divided by negative 2. So negative 2 over negative 2 is equal to 1. My vertical asymptote is going to be, in this again, x equals 2. And since I've got a quadratic over a linear, I know I'm going to have a linear oblique asymptote that's going to describe my end behavior. And so here, again, I just have to divide. So I'm going to go back to the original equation here. So now while I'm dividing by 2x minus 4, okay, this is where we need to be careful here because I need to factor out this 2. All right, so let's remember how this works. So y, I'm not going to rewrite this original one. Okay, I'm going to factor out the 1/2. Okay, which essentially is factoring out the 2 in the denominator. So we've got I'm going straight to the synthetic division. So x squared plus x minus 2, all right, divided by x minus 2. And so I have to perform my synthetic division on this expression here. Okay, so remember, synthetic division only works when the leading coefficient is equal to 1. So let me do the division on the side here. So we've got 2, and so here we've got 1, 1, negative 2. Okay, so 1, 2 times 1 is 2, 1 plus 2 is 3. I don't actually care about the remainder because I know that's going to be approaching 0. So here, this is going to be 1/2 times, well, what does this give me? X plus 3 plus some remainder term which is unimportant to me. The only thing I care about is the equation of the line. And so my oblique asymptote is going to be, so don't forget, I have to reintroduce this 1/2 into my expression. So again, this is what people often forget. So my oblique asymptote is going to be y equals 1/2 x plus 3/2. All right. So let's just recap. When you're determining these characteristics, step number 1 is to factor to see if anything reduces. And then once you've done that, if anything does reduce, you'll get a whole. And if not, you can start determining all the characteristics. When you have a rational function where the numerator is 1 degree higher than the denominator, you are going to have an oblique asymptote, and the way you find that oblique asymptote is by finding the quotient of this division. And again, remember that when you're dividing by a linear that does not have a coefficient of 1, you need to factor that coefficient out first. Okay, that's it for this one.